And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and we're showing you a still image here from the coronagraph on stereo A, and we'll tell you about why in just a moment. Today's video is going to be about things like tutorials, pest eradication. We'll be advertising today's Smash Lights, which will not be included in today's video, cosmology stuff, what not to do, playlists, and here's an example of what not to do. Don't show your viewers an image like this, where this artifact does not have anything to do with what's going on in the sun. As you can see, the corona doesn't just suddenly do that, and there is some damage on the coronagraph disc here at stereo A. I mean, it's been a known thing. If you look right here, you can always see a bit of twinkling happening there. So some sort of damage on the disc, and it's been there as long as I remember. But so the point is, sometimes things strike the aperture, like a cosmic ray or a bit of plasma from the sun, perhaps, and that does not mean that the sun is doing that. So I just wanted to start out with a view from stereo A, and for you new viewers out there, if you're wondering what's up with stereo A, head to the stereo website. If you're not familiar with it, it's stereo.gsfc.nasa.gov. And stereo A is out here at Lagrange point 5, unlike the SDO, which is at Lagrange point 1. And if you're wondering where the other ones are, there's 2, there's 3, and there's 4, where stereo B is located. Yes. So we look at that because when you're looking at it from this type of a viewpoint, you can see coronal mass ejections that are headed earthly, in direction, earthily. So I just wanted to show that little diagram there to give people a clue. Now we've gone to Lagrange point 1, so in between Earth and Sun, we're looking at the view from SOHO, and you can see sort of the tail end of yesterday's coronal mass ejection, mostly headed out here to the west. And I wanted to talk for a brief moment about the heliospheric current sheet. We'll get to it after looking at the C2. Here's the LASCO C2, and yeah, it's a zoomed in image of the same thing from the SOHO suite of instruments. And there could be some Earth-facing ejecta with that. It would be a slight glancing blow of diffuse stuff. Not a big deal. Nothing like a coronal hole wind stream, for instance. Now, about the heliospheric current sheet. The sun has a rotational period of about 27 days. It's called the Carrington rotation. And as things are flung off of the sun, the solar protons have a tendency to travel on curved paths. So this object is spinning, nearly 3 times the orbital velocity of Mercury, and so on. It's spinning about 12 times as fast as the Earth's orbit. And so there's some speed disparities here. And as the plasma erupts out of the corona, you get these current sheets. And they're usually charged by one pole or the other. So if for instance, if Earth's potential field force lines are going through this current sheet, it has to decide, is it going to be North Pole or is it going to be South Pole? And that's what we're talking about daily, the heliospheric current sheet. And so when you're looking at it from the Earth, you're looking edgewise on the current sheet. And are we going to talk any more about... We're going to talk more about what not to do today. Survey said? Sweet. I'm getting better at these. I'm getting them wrong, but I'm still liking the answers. It's fantastic. Next, we're looking at an animation here on the browse data section. This is part of the SDO. The browse data section. We're looking at 94 angstroms. And we don't see any sunspots. A little bit of magnetic organization happening down here. And this is one of the cool things about the browse data. It's very easy to focus on certain portions. You can rock the animation back and forth. It's just a series of images, and you can actually download all the images to make your own custom animations if you like. And let's head to HelioViewer movies. We got some great helioviewer.org movies. Some amazing filamentary activity. Now keep in mind, folks, the Earth is not there. That's there for scale. And we're going to show you the 171 angstroms after this next run. And I check the life of the stream. And again, thanks everybody for tuning in. Here's 171 angstroms of the same full disk view. And we've got some interesting filamentary activity down there in the southeast. And we've got an amazing close-up of it. Oh man, it's a great day for cosmology, as we have another MOST to add as well. So here's that filamentary behavior, and talk about details. Fantastic detail there. It actually looks like a corkscrew. If you pause the image, you can see sort of a corkscrew formation. And very interesting there, you can see the plasma orienting to those magnetic field force lines. And this is one of the mechanisms that causes not only coronal mass ejections, but also solar flaring. Depending on how those fields interact, the plasma must align itself to the magnetic fields, folks. So that's just a fantastic image. And here it is in 304 angstroms, and this one's in some ways even better. Now again, folks, keep in mind, the Earth is not located there. But you can see the size of that filament area, and it's located very far south and very far east right now. But because it's on the limb, it's providing some quality fireworks. And we are coming at you today from the Smash bunker, and we are streaming live to Twitch. The radio flux has dropped back down to 69 solar flux units. There's the last cycle's 10.7 centimeter radio flux progression. We are still above 70 in smooth monthly values. KP index has dropped back down to 0. We don't see any sunspots. We don't see any solar flares. We don't see any significant plasma strikes in terms of proton flux. Know the difference between your photons and your protons. All right. Next real-time solar wind. And we see a little increase in the solar wind density there and the speed. Up to 10.2 protons per cubic centimeter. So a little uptick in the solar wind density there. Solar wind speed still incredibly low. Even a little lower than it was yesterday at this time. 279 kilometers a second. That's about as low as you see it. And here's what's going on in the magnetosphere according to the space weather modeling framework. You can see very, very large plasma spheres here. And you can see some multiple layers forming, especially on the meridional plane view right there. And those empty spots, that's where the plasma amasses. It gets held in place by the Van Allen belts. And we've got interesting stories about the Van Allen belts to cover. Here's 4 hours, like the last slide, of ground magnetic perturbations, and we show this daily due to the fact that there is a polar excursion going on right now, which is probably largely in charge of the strange weather conditions that you might be noticing. It's not caused by carbon dioxide. All right, so anyway, let me just put this back to where it was. We don't see that many magnetic perturbations here, but these are chiefly magnetic perturbations here, not so much solar radiation, solar proton-induced, I'll say. Power outages are clearing up a little bit as the West Coast burns. People are displaced in the tens of thousands from Oregon, I've heard. So quite a bit of power outages there. Utah still 50,000 out, and Louisiana still 111,000 out. Shout out to our Louisianan viewers. We hope things are mopping up eventually down there. GOES magnetometer is still looking a little wild here. I'm expecting it to smooth out a little bit. And I expect us to stay solidly in the North Pole current sheet, which we show here in green. This is part of the Gong 2 suite, part of the National Sunspot Observatory. And it uses stereo A, stereo B, and Earth-based magnetometers to calculate potential field force lines. We don't really see a lot of activity there. Again, expecting to remain North Pole current sheet and the magnetometer to smooth out a little bit. Here is the line of sight field plot, which shows you the B field also in blue. And no major perturbations in the B field. But still tons of stuff to cover. Here's the potential field force plot of the corona. And just keep in mind on the dates on this, folks, this goes all the way back to mid-August. I just like the graphic. I think it's fantastic. Now, today's smash lights is not going to have anything to do with the daily space weather. So we are going to make a smash lights. It's just not, it doesn't exist yet. So in any case, don't forget to check out our playlists. Please press like and subscribe on YouTube, etc., wherever you watch. And we would invite you to make Earth not suck again. We've got shirts depicting this, if you'd like to check those out. You can link to all that stuff at smAsho.org. Thanks to our YouTube, our BitChute, and our Twitch viewers. Let's talk cosmology. Guess what? It turns out dark matter is not uniformly distributed as it should be in gravitational models. So there's an article here about how, whoops, there must be a missing ingredient in the cosmic recipe. Well, who would have guessed? Well, everybody who's been paying attention, at least since the mid-1990s. So I didn't take astronomy until 1994, I believe it was. And I was already making fun of WIMPs back then, weakly interacting massive particles, otherwise known as dark matter. One of the more accepted theories of dark matter are weakly interacting massive particles. There are a few different ideas about them, and this one's talking about lensing. I don't really want to talk about lensing that much, but in any case, we've got some more interesting astronomy stories, such as ultra-relativistic electrons above your head right now. Now, I've told people, and we've got viewers who believe that the Large Hadron Collider causes sunspots to form and insane ideas like this. And, you know, I try to inform them that there are relativistic particle interactions going on right above your head, because there are giant belts of electrons circling the planet, and some of them get accelerated to ridiculous speeds, ludicrous speeds perhaps, by things like solar induction. So multiple layers form and you get increased pressure in the Van Allen belts. We even get multiple Van Allen belts, actually, when coronal mass ejection strikes hit, and during coronal hole wind streams for that matter. So an interesting article here from German Research Center for Geosciences about how those electrons can be accelerated. You're talking about ultra-relativistic here, 100 billion degrees Fahrenheit estimated. And yeah, it's interesting. And like I said, there are extremely high energy reactions going on above your head right now, depending on what part of the Earth you're located at. Let's talk about the way stars form. Now, astronomers arrogantly believe that they know how a star forms, yet we've never seen one form. Astronomers also arrogantly believe that they know how a star dies, if a star dies, and what the mechanisms are. Now, that's not true at all. And we see various examples around in astronomy about stars that shut off and turn back on. So this is an ongoing debate, as the word star-forming regions is just thrown around willy-nilly in the world of astronomy. It's part of the reason why people like Eugene Bagashov consider cosmology a gosh darned science, a son of a beehive type science, which defames your own credibility if you talk about it too much, because there's so much conjecture built upon nonsense. Now, TW Hydrae isn't nonsense. It's a star at approximately 163 light years from Earth, and it's a variable star. I don't want to spend too much time on this because we've got some even more interesting stories to cover. However, taking multispectral imagery of close stars is a good idea. and the data is always helpful, even if the theories behind what's going on with the data are not. So we welcome most spectral analysis in this fashion. We just have some disagreements about mainly what stars are composed of. So without going any further about that, let's talk about pulsars. Now pulsars are a type of neutron star which has a field rotation going on, most likely. And how it works is not fully understood, but the strongest magnetic field in the entire universe has been detected by a Chinese X-ray space observatory. So we've picked this one up at smAshomash.com/forum. In the cosmology forum, we have an entire forum on cosmology, and then there's a thread called The Most. And it includes things like basic stuff like the most massive planet in the solar system, the most massive object in the solar system, but it also includes extremophiles. And this pulsar is an extremophile, to say the least. Pulsar GRO J1008-57. Another catchy name. Perhaps we should suggest a name. What about the Teslatron? I think Teslatron would be an appropriate name. Please leave a comment if you agree with Teslatron. Let me update forums. Should this be named the Teslatron? And part of the way that we measure this is by looking at synchrotron radiation. So when you use, again, wide spectral analysis, you can get an idea of what's going on the very small scale, and I guess at a very high temporal resolution. If you want to read about cyclotron radiation, it's when an electron is forced to make a very sharp turn. So, yeah, I thought I had an image. Cyclotron radiation. So, when an electron is forced to make an extremely sharp turn, the point of most resistance can cause it to emit photons. Synchrotron radiation is slightly different than cyclotron radiation, but they are related. Anyway, if you want to learn more about GRO J1008-57, it is monitored at the Neil Gehrels Swift Observatory. Just hit Control F and type in J1008, and you'll find it on the first try. The high mass X-ray binary / neutron star. And you can see it's had actually an interesting periodicity here. Fairly regular pulses from this. A super interesting object to look deeper into. Here's a zoom in on it at Simbad, and you can link directly to that from the Neil Gehrels Swift Observatory. Super interesting. J1008-57. The strongest magnetic field ever directly detected by an X-ray observatory. I guess that's a mouthful, right? It's still the most. It counts. Head to smAshomash.com/forum. By the way, thanks to our subscribe stars and to our patrons, a true source of funding for the content. As YouTube pays us almost nothing for these videos, it takes us about well, this time it's taken about 8 months for us to get even a payout. So yeah. Thanks again to our patrons, the true source of funding. YouTube endeavors to pay us nothing through demonetization, throttling, and shadow bans, I assume. Consider becoming a patron at patreon.com/smAshomash. You'll get some information first, as well as various media. I do graphic design and music production. And by the way, if anybody would like to hire me for graphic design, I'll give you a killer rate, as you must be one of our viewers. I'll give you a discounted rate to do graphic design, depending on what it's for. Let's get back to space data by looking at the 1-year graph of the electron flux. And we're still in pretty high levels here, but we did see a dip finally. probably associated with that increase in the solar wind density. Will we still get back into storm levels today? Probably. Keep in mind these M's mean midnight and the N's mean noon for the GOES 16. And of course, the highest concentration of electrons is where the sun is at noontime. So this gives you a good idea of at least 1 point measurement of the F2 layer as the GOES 16 measures the electron flux at the F2 ionosphere layer, or it endeavors to. Next, looking at charging hazards, we don't see any. Looking at the total air column to see significant GPS errors here, quite distantly from the equator. So lots of electrons out there, as well as significant electron flux happening at nighttime. And I think we're going to see a little dip here in the electron flux. Let's see what NOAA's forecast is. And there's the forecast model. Looking at just the ionosphere layer, and it's looking quite anomalous here on the sun side. Over the past 24, some oddities. And by the way, we saw a 6.3 magnitude quake as we did show prep today. So it was unexpected, and I think it happened right as I clicked on the USGS map. There's the current state of affairs in the ionosphere, actually quite discharged on the sun side. You can see it's only reaching to 8 megahertz, I think. Next, looking at planets, etc. Here's where they are now. Here's where they'll be in a week. And for all of you fearmongers out there, here's something to frighten people with. It's very scary. You've got Venus, the Earth, Mercury, and the Sun making a nearly isosceles triangle here, suggesting that Frito-Lay may be attempting to take over the galaxy, starting with our solar system. So please tell your favorite YouTube conspiracy cretins. And please use the word cretin and imbecile as much as possible. Cretin and imbecile. Those are smart people words for dumb people. Next, looking at in-the-sky. I'm always interested in what's going on above my head. And I got up at 4:30. I got up at like 2:30 to make this video for you today, folks. If you're up before dawn, you may see the Mars, the Moon, and the Venus. The third brightest object in the sky at a magnitude negative 4.2. Yowzers! And here's that quake we're talking about. It's that 6.3 at Chile. Let's scroll up the list because there's not a lot of action besides that. Although we do see a deep quake in southern Mexico here. It's a 4.4 magnitude at nearly 200 kilometers. Here's a Myanmar quake. 126 kilometers depth. 4.3 magnitude. Let me just check the stream life. I think we are good. I hear noises. I don't know what they are. Perhaps I'll have to go investigate, heavily armed. Another deep quake at Chile. So there you have a perfect example of a foreshock at depth, very close to where the larger magnitude quake happened. That 4.3 came in at 1957, so just before 8 o'clock Universal Time last night, we see a 131 kilometer deep quake, followed by a 6.3 this morning. And another deep quake right in the same region, a 4.6 magnitude at about 1 o'clock Universal Time today. A deep quake in the Mariana Islands, so a bit of a deep quake event there, mainly on South America. Expect to see lots of aftershocks in Chile after that 6.3. There's a deep quake south of that spot. And let's hope that 6.3 is not a foreshock. The depth of the 6.3 quake was 40 kilometers, and it came in at 7:33 Universal Time. Next, looking at volcanoes here on volcanodiscovery.com to see Abico's erupting. It's producing a 10,000-foot ash plume. Manam also erupting. Explosively, flight level 080, 8,000 feet. Tokono exploding. Flight level 070, Sangay exploding. Flight level 200, it's a 20,000 foot ash plume. Revenador likewise exploding, 15,000 foot ash plume there. Sabancaya exploding, 24,000 foot ash plume there. And don't cop a feel of Coppahue, because the activity of the volcano has remained essentially unchanged, characterized by continuous ash emissions with incandescence visible from crater at night. Perhaps it's a good time to throw a virgin in there and sacrifice her to some sort of volcano god or something like that. I'm sure that'll bring rain or stop the floods or something. Anyway, we've still got some hard freeze warnings here in the northern plains, as well as some frost advisories in Maine and air quality alerts, no surprise, as the west coast burns. Left coast. Left coast. Not a low pressure system. Yeah. Let's talk about an article on phys.org to apply it to real science. Now, for those of you not aware, for some reason, Antarctica began to glaciate about 33 million years ago. And guess what the temperature was? Well, it was 3 or 4 degrees Celsius warmer. That's degrees Celsius. Yeah, it was warmer than it is now when Antarctica began to glaciate. Were you aware? Now, this chart here has looked very scary. As you see at the end of this, oh my God, look, it's going to be 15 degrees hotter. And this all has to do with the incorrect assumption that carbon dioxide mitigates temperature on the planet. If you want to read that one, just head to, oh geez, I think it's on phys.org in the Earth section. It's also on SciTech Daily. Fraud. So anyway, they're looking at 66 million years to make it look scary and to try to institute ridiculous things that will not have anything to do with the climate. I just wanted to show you this graph because a lot of people are not aware that Antarctica formed when it was about 4 degrees Celsius warmer than it is today. That's for all the people that think it's going to melt, that Antarctica is going to suddenly melt. Oh my God, the ocean. By the way, it's winter down there right now. And let's do another tutorial here on Tropical Tidbits. When I go to Tropical Tidbits, I go to the forecast models usually. Today I'm going to go to regions. So if you got to do a region that you're not used to doing, well, I'm going to go to the North Atlantic. Why? Because I've heard there are like 7 systems in there. So let's do a run for total precip. It's going to make for some rainy days in the ocean. And also some on Bermuda, it looks like. As well as a system striking Western Africa. Not a lot by way of rain hitting the U.S. And that's the GFS forecast here at TropicalTidbits.com. By the way, we're not paid to tell you that. We do it at massive personal risk and expense. Next, we're going to do a run at windy.com. Now, they've got a great mobile app, and I'm not paid to say that either. In fact, I'm not paid to do much. Everybody wants me to pay and wants me to be accountable for stuff that's their fault. Anyway, here's where we expect pressure to be tomorrow, around 1 p.m. my time. Very strong low here in the North Pacific. This one up here is pretty beefy too, but not as concentrated as that one. Look at the isobar lines. Holy criminy. Oh my God. I wish Higgins would say it on Magnum PI. Oh my God, Magnum. That would be, wouldn't that be great? We see some terrestrial lightning here. None strike in the U.S., so I'm not going to say, hey, there's thunder rolling in. Next, looking at water vapor maps. Here you go, African and European viewers. There's your water vapor map. Here's a water vapor map for other international viewers in places like Oceania. and the Far East. Please leave us a comment if you're located underneath this map. Next, looking at the U.S. Doppler radar map at Weather Underground. And there's still some snow falling in Colorado and Wyoming. As that low continues to rotate, you can even see the rotation on the Doppler radar map. It looks like things are mopping up here in Pennsylvania, and I'm about to be mopping up some pests. Perhaps I'll talk about it more in the Smash Lights section. Here's what's going on in the cloud layer. And you can see that somewhat counterclockwise rotating system there, mainly over the Colorado-Wyoming border. And you can see it much better on the water vapor map. Let's zoom in on it, as it's not too exciting in my neck of the woods. Let us know what it's like in Colorado. I heard there were 40 inches of... I saw a forecast of 40 inches of snow in some areas around here. Still a significant low pressure zone there, and it's pretty encased by dry, massive air. And let's move on to the jet streams. Check out this extreme meridional jet stream flow. It's a massive, massive anticyclone with a legit clockwise rotation here. Jet stream scale anticyclone there, folks. Now, for those of you not aware, Jupiter's Great Red Spot is an anticyclone. It is a high pressure zone, not a storm. It's not a storm as you would call a storm. It's a pressure on the planet, not an uplifting low pressure. It's a high pressure, like an anticyclone. Get it? Check out the jet streams in the south. All right, here are the western jet streams, if there are any. Tripled up in the south down there. And you can see all over the place. Significant rotating low there in the North Pacific as well. Holy cripes. Oh my goodness. Hey, Smash Team, it's time for me to vanish and make another video and get this video going. Now, if you haven't checked out smashamash.org and the links there, one of the things you could do is you could join the Smash team by perhaps purchasing a shirt with our logo on it and our website. Tell people where to go. You can go straight to smashamash.org. Thanks for flying American Smashways. Please keep your head and arms inside the Smash plane at all times. We're going to show you the 193 angstroms 48-hour SDO video, a colorized magnetogram, and it's updating before your very eyes. Now, of course, this video's live, so is it live or is it Memorex? Here's the intensity gram to show you 0 sunspots. I don't see any sunspots. Do you see sunspots? You probably don't spit on your monitor as much as I do. I've got to clean it like on a weekly basis. And here is the 193 angstroms view. Some coronal holes associated with the south solar polar field. And once again, we see an active region associated with coronal holes. I think there may be a mechanism there. I'm not going to discuss it in today's video, as we don't want it to be too long. Please leave a comment if that's what she said. And may that solar wind be at your back and that covidiousy absent from your locale. All right, covidiocy. I've had, to quote Jim Kirk, I've had enough of you. It never fails.